Heyo, this is Miss Eisencraft with Unit 3, Lesson 5, lesson recap. So, this idea, or the big idea of this lesson, really is following up on some big ideas from Lesson 4 about scatter plots, looking at how two numerical data sets like correlate with each other or are related on a coordinate plane. So, and then we're going to kind of remind ourselves, okay, if they correlate and we can draw a line to model that, how can we describe that learning what we learned in middle school about straight lines? So, one of the first things to look for when you have a line of best fit, this is what they call that blue line, is what is how good is the fit? And I kind of look at it like almost like a magnet, right? Like if the blue line was magnetized and these were like little magnets and attracted, which one is the strongest? And it doesn't have to be perfect, but the blue line is kind of indicating the trend through a straight line. So you can kind of see here, A is a really strong or a good line. It's a good line of best fit, where maybe, even though C has a couple weird points, A and F is more loosely, demonstrating the trend of the line, but still it is showing the trend of what the data is doing. Excuse me, the line is showing the trend of the data. Okay. You also, in this lesson, were reviewing things like slope. So when you draw a straight line, you want to describe which one, the slope describes the rate of change, like how quickly the line is increasing or decreasing. And we do describe slope going up to the right as positive and down to the right as negative. But if you just want to say which set of points have like the greatest rate of change, you wouldn't really need to look at positive or negative and say, this graph here, E looks like it's a really great rate of change. It's pretty steep. It is going down. It's a steep negative slope, and F is fairly steep, and maybe A as well. B and C aren't so steep. So the slope is another way we can describe how closely or the correlation of the two data sets. This lesson also covers the vertical intercept or the y-intercept. And a lot of times in 8th grade, we think of that as the starting point or the value for the y value when x is 0. And in context, like in the word problems, that makes a little bit more sense. But oftentimes when we draw a linear model, this might not make a whole lot of sense because it might not make sense for 0, but still the linear model shows the trend for the rest of the dots. But it does help us write an equation, which will help us make predictions. So we do need to look at the vertical intercept, so where it would cross the y-axis or the vertical axis. Okay, those are reminders from 8th grade. So some things to also consider is that just because you have a scatter plot doesn't mean it will follow like a linear trend. Specifically, if you look at G here, this is a terrible model. This in no way indicates what is happening here. This looks like it's circling down, scooping down and then back up, which this blue line doesn't really in any way indicate that trend. Linear models should be used when you could draw a line through the data, and in general, it is showing what the trend of the data is doing, even if it's a little loose. Okay, another bad example would be this one here. It's not showing the true trend of the data. And when we describe what the trend of the data is doing, we often talk about what is happening as X increases. So let's take a look at E. And we want to talk about what is happening. I always think, okay, march forward on X. As X is increasing, what are the dots doing? As you move to the right of the graph, as X is increasing, as you go to the right, the Y values are decreasing. And that will often help you understand the correlation between these two variables when these are words. Okay. And finally, They are going to ask you to not only draw that line, describe how, is it a good line? Does it really model the trend? But more specifically, can you tell like that trend line, what is it saying about your two, sets of data? So here we would have the length of the pencil and the time sharpening of the pencil. And it looks like as the time increases sharpening the pencil, you're sitting at the sharpener forever, the length of your pencil is going to decrease. Okay. And that line of best fit can oftentimes give us an equation. And I just want to remind you guys, there is this guy, right? We learned, oopsie daisy. I don't want that. No, thank you. And no, thank you. And please leave. Thank you. Okay. So we have here, this maybe was like pounded into your head in middle school. If not, let's do it now. This is a nice form of a straight line, an equation for a straight line or linear model, where this is the slope and this is the y-intercept. You also can rearrange it in context. Oftentimes you can talk about the starting point and talk about something increasing or decreasing at a certain rate, and that is the slope right there. The m is the slope. So when they switch that around on you, it's still a linear model. So here, this the 150, if you look on your graph, hey, that's talking about if you haven't spent any time sharpening your pencil, that is the original length. And then the slope, I always like to put a 1 underneath it so we can have another number. This is the change in y, the change in how many millimeters of the pencil length is going down, I guess, the decrease of the pencil length every 1 second. So it looks like every second you sharpen, you're losing about 5 millimeters of length. So they're going to ask you to interpret that in context. And if it's written in y equals mx plus b, you can think of like that b as the starting point, right? And then the slope, if it's positive or negative, in this case, it was minus 5x as the rate that it is increasing or decreasing. And again, not all the dots are the same, but we use the line to describe that. Okay, hope that was helpful for explaining briefly what lesson 5 was all about.